Virtual vacation live stream. Turn on the comments and let's go to Chat GPT. What's the wrong thing? We'll jump right in here. So we're going to the asteroid belt today. Wonder if we'll actually be out there. It's about 50 years from now. Oh, it's actually not that populated. So that's one thing it's wondering. Like, there's really, you'd probably be able to see like one asteroid at a time. It's not really a whole bunch close to each other.
You've arrived in the asteroid belt in
So,
the year 2075. The view from your spacecraft is awe-inspiring. Countless asteroids float in the vastness of space, illuminated by the distant sun. Some asteroids are equipped with advanced mining machinery, and several other spacecraft are visible, either mining or traversing the belt. The control panel in front of you displays holographic navigation and mining data, enhancing the futuristic feel of this adventure. What would you like to do next? Would you prefer to explore a nearby asteroid, observe the mining operations, or travel to a different part of the asteroid belt?
kind of surprised the current AI got that wrong. I would have expected an earlier AI to get that wrong, but guess that is how it's portrayed in the movies and stuff. But it's not that many asteroids. It's not that dense. We could go visit one of each type actually too.
The
So
computer
learning a little
responds,
astronomy here
detailing the
too.
different types of asteroids you can encounter in the asteroid belt. 1. C type, carbonaceous asteroids. These are the most common, making up about 75% of known asteroids. They are rich in carbon, giving them a dark appearance, and contain clay and silicate rocks. 2. S type, silicaceous asteroids, comprising around 17% of the asteroids. These are made up of silicate materials and nickel iron. They are relatively brighter than C types. Number 3. M type, metallic asteroids. These make up most of the remaining asteroids and are composed mainly of nickel and iron. They are known for their high metal content and are often targeted for mining operations. 4. D-type asteroids. These are rare and are known for their reddish color due to their organic-rich silicates and water ice. They are found primarily in the outer reaches of the asteroid belt. 5. Similar to D-types, but more common, P-type asteroids have a dark appearance and are believed to contain a mix of carbon-rich compounds and water ice. Would you like to investigate one of these types of asteroids more closely, continue exploring the belt, or perhaps join a mining operation?
Oh, we're doing asteroid virtual vacation. So let's go check out a carbonaceous asteroid. Feel free to let me know if there's anything you want me to do while I'm out here. So
You've arrived at a carbonaceous C-type asteroid. The asteroid's dark and rugged surface is rich in carbon, a stark contrast against the backdrop of space.
Doing pretty
Your
well.
spacecraft's
And
robotic
you?
arms are poised to attach to the asteroid, ready for exploration. The control panel displays detailed information about the asteroid's composition and the ongoing mining operations. What would you like to do next? Would you like to deploy a probe to gather samples, use the robotic arms to start mining, or explore the surface on foot with a spacewalk?
Be cool to do a spacewalk and check out the surface of it. I believe from my astronomy memories or like my class memories of my astronomy class, I believe this is correct about the different types of asteroids.
You've stepped out onto the surface of the carbonaceous asteroid. Your gloved hands reach out to touch the dark, rocky terrain. The surface is rugged, dotted with craters and carbon rich rocks. In the background, you can see the mining equipment and robotic arms from your spacecraft. The distant sun casts a faint glow, while stars twinkle in the blackness of space. What would you like to do next? Would you like to collect samples, investigate a nearby crater, or return to the spacecraft?
Guess comment on the weirdness of this picture. He's got like 6 fingers. Like he's on an asteroid holding another asteroid. Like, looks like there's solar panels and stuff around and like this weird planet there. Yeah, it's interesting. Seems like it does better with Earth destinations, but at least it's got the dark color of the carbonaceous asteroid, right? Be interesting to see what we get elsewhere. Let's see what the other types were. It's interesting. The carbonaceous ones would be the harder ones to spot, I think, too. It's weird. It's like putting a smaller one on a bigger one like that.
You've reached a silicaceous S type asteroid. Its surface is noticeably brighter than the carbonaceous one, with silicate materials and a metallic sheen from nickel iron. The control panel displays data about the asteroid's composition as the spacecraft's robotic arms prepare to attach to it. Mining equipment is already visible on the surface, indicating active operations. What would you like to do next? Would you prefer to explore the surface on foot, deploy mining equipment, or examine the asteroid's metallic composition more closely?
Actually, examining the composition of it would be nice too.
You're now exploring the surface of the silicaceous S type asteroid. The bright metallic terrain reflects the distant sunlight, and your gloved hands reach out to touch the silicate materials and nickel iron. Mining equipment and the spacecraft's robotic arms are visible in the background. The surface is rugged, with various craters and reflective rocks adding to the otherworldly scenery. What would you like to do next? Would you like to collect samples, investigate a specific area of the asteroid, or return to the spacecraft?
Yeah, that definitely just played it weird. We're out in the asteroid belt exploring different asteroids and it's doing a little weird on the image generation. Most of it. In the year 2075, exploring the asteroid belt. Feel free to let me know if there's anything special you want me to do while I'm out here, too. Actually, throw a chunk would be kind of interesting. Oh, I should have said it. Shout yeet. Right, you'd only be able to hear it in your own spacesuit. Wait, that looks weird.
You pick up a bright, metallic rock from the asteroid's surface and throw it into space. Watching it float away into the void, you see the rugged asteroid behind you and your spacecraft in the distance. Stars twinkle around, and the faint glow of the sun adds a surreal touch to the scene. What would you like to do next? Would you like to explore more of the asteroid, head back to the spacecraft, or maybe travel to a different location in the asteroid belt?
Looks like by the image, I'm inside the spacecraft already. Throwing the asteroid inside the spacecraft, that's weird.
You carefully collect a sample from the surface of the silicaceous asteroid. Once back inside your spacecraft, you place the sample into the onboard analyzer. The control panel lights up, displaying detailed information about the sample's elemental composition. Silicon, 45%, oxygeno, 30%, nickel Ni, 10%, iron F, magnesium emium, 5%, trace elements, 2%, including aluminum, calcium, and other metals. These elements make up the core components of the silicate materials and metallic content of the asteroid. What would you like to do next? Would you like to explore another type of asteroid, continue mining, or perhaps return to the spacecraft and head to a different destination?
Yep, hi there. Doing well. How about you? Out in the asteroid belt today, and looks like the AI is having a little bit of image trouble with it. At least get to laugh at some of the images. We already had, guess I had 6 fingers on one part. Oh, that's cool. That's really cool. Like with a got a girlfriend. That's really cool. Okay, let's see. And we'll go visit the next type here. Huh, that's actually interesting. It's lower carbon, if that's correct. Oh, cool. Yeah, I like it too. Yeah. So let's see. What were the other types here? I think there's a P type. Yeah, let's see. M type. That's gonna be an interesting one. See, I guess doing the virtual vacation to the asteroid belt is what I'm doing right now. And earlier today I worked and played a little grounded, did a bit of chores. So, see what we got on the M type asteroid here.
You've arrived at a metallic, M type asteroid. Its bright, shiny surface, composed mainly of nickel and iron, reflects the distant sunlight. The spacecraft's control panel displays detailed data about the asteroid's metallic composition. Robotic arms are getting ready to attach to the asteroid, and mining equipment is visible on the surface. Stars twinkle in the background, adding to the stunning view. What would you like to do next? Would you like to go on a spacewalk to explore the surface, start mining operations, or collect a sample for analysis?
Oh, that looks cool.
You're now on the surface of the metallic M type asteroid. The bright, shiny terrain is composed of nickel and iron, with smooth, reflective patches and small craters. Your gloved hands reach out to touch the cool, metallic surface. Mining equipment and the robotic arms from your spacecraft are visible in the background, while the distant sun casts a reflective glow. Stars twinkle in the vast expanse of space. What would you like to do next? Would you like to collect a sample, start mining, or explore a specific area of the asteroid further?
Now that's actually pretty interesting. That's actually a pretty decent picture there. I think. So
You carefully collect a core sample from the metallic asteroid and place it into the onboard analyzer. The control panel lights up, displaying the detailed elemental composition of the sample. Nickel, 60%, iron, Fe, 35%, cobalt, O, 2%, platinum group metals, 1%, other trace elements, 2%, including gold, silver, and copper. The high metal content confirms the asteroid's suitability for mining valuable resources. What would you like to do next? Would you prefer to continue exploring the asteroid, engage in mining operations, or travel to a different location?
that way I just don't have to scroll back up. So we did C, S, M. Okay, now we got D and then P. I don't know if I have yet there. I have to check that out. Are you on the Galactic Hub? The one I like a lot. The one I say, like, I love that level. We'll go to A. There's multiple. I have to check that out there. This may actually end up being a short one unless we want to do some cool stuff on each asteroid here. Or on the in the asteroid belt. Can anybody think of anything they want to do? Oh, it's taking a little bit of time to generate the image here. If we're not running into issues here. Let's see. I guess I could have it read this off while it's trying to generate that.
The computer provides a summary of the different types of asteroids in the asteroid belt. 1. C-type carbonaceous asteroids comprise about 75% of known asteroids, rich in carbon, dark in appearance, contain clay and silicate rocks. 2. S-type silicaceous asteroids make up around 17% of asteroids, composed of silicate materials and nickel iron, brighter than C-types. 3. M-type metallic asteroids, composed mainly of nickel and iron, known for high metal content, often targeted for mining operations. 4.
Oh, I'm
D-type
sorry to hear that.
asteroids, rare and reddish in color, organic rich silicates and water ice, found primarily in the outer asteroid belt. 5. P-type asteroids, similar to D-types but more common, dark in appearance, contain carbon-rich compounds and water ice. Would you like to explore another type of asteroid, continue mining here, or travel to a different location.
Okay, let's copy and paste that. Let's see if that'll work. Wait, I'm not sure what just happened there. Let's see if there's a way I can make it stop here. It seems like it's a little stuck here. 45 actually. Oh, and how about you, if you don't mind? See, I think I'm gonna go ahead and start this over here, and we've already visited. So we got the D type and the P type asteroid to explore. Let's just go ahead and start a new one. Oh, cool.
You're now floating in the asteroid belt in 2075, gazing at a P type asteroid. The dark, carbon rich surface glimmers faintly with traces of water ice. Mining drones hover around, extracting valuable materials, while a small base nearby hums with activity. The distant sun provides a dim, ethereal glow, illuminating the endless expanse of space dotted with stars and other asteroids. What would you like to do next? Explore the mining base, interact with the drones, or maybe take a spacewalk around the asteroid?
I'm not sure actually. I think maybe my guess would be around $1,000. iPhones are expensive, but this can work on. Pretty much you can do this on phone, any phone, just about, or any smartphone that can go to the internet. I think, and you can also do it on the computer. So it's pretty much web based. It's on Chat GPT. It's if you search in the GPT store, it's virtual vacations anywhere, anywhen. I actually made this. Made this custom one here. So I don't think I have to specify every time because I think it keeps track. It does keep track pretty well of what we're doing. So man, dog's really good.
You're now on a spacewalk, floating just above the surface of the P type asteroid. The terrain is dark and rugged, covered with patches of water ice and a fine layer of carbon rich dust. Reaching out, you feel the rough texture through your gloved hand. Mining drones buzz around, diligently working, while the small base gleams faintly in the distance. The infinite void of space, adorned with distant stars and other asteroids, envelops you. What would you like to do next? Collect samples, explore the asteroid further, or return to the base?
Oh yeah, I'll try. Maybe tomorrow. I'll try to do a live one here. I've actually got some Monopoly Go videos that I need to upload too. So. 8:24 here p.m. Oh, am I? I'm not sure when I'm gonna be doing the Monopoly Go thing. Probably sometime in the morning though. Maybe around 8, 7 or 8 in the morning. So guess 11 hours maybe from now.
You're extracting a core sample from the asteroid's surface. The cylindrical piece reveals distinct layers of dark carbon rich material, interspersed with patches of water, ice, and rock. As you operate the tool, the mining drones continue their tasks, and the small base remains visible in the distance. Space stretches out around you, filled with distant stars and asteroids. You ask the onboard computer to analyze the core sample. The computer responds, analysis complete. Core sample contains 40% carbon rich compounds, 30% silicate rock, 20% water ice, and trace amounts of nickel and iron. What would you like to do next? Collect more samples, explore a different part of the asteroid, or return to the base?
I'm not sure how that works actually, and I don't think they like you doing that. I think there is. I think it may be possible to do that, but I'm not sure. Monopoly Go, I take it you're asking, right? Okay, so let's see. Okay, what was the other type? I think it's D type. Yeah, I think it's D type. I think it'd be interesting to upload my story to Planetary Settlers on here, and we could effectively play Planetary Settlers this way. I should make. Ooh, I should do that. I should make a custom GPT that's effectively my Planetary Settlers game. That'd be cool. That's on Steam if anybody's interested in that. That's for PC. Space exploration game. So I should make an asteroid like this in there to explore too. Got the different planets and a comet to explore, so and the moon.
You're now approaching a D type asteroid in the asteroid belt. Its reddish brown surface has a smooth texture, rich in organic materials. Mining drones are busily extracting resources, and a small base with lights and equipment is nestled nearby. The distant sun casts a faint glow, illuminating the vast expanse of space filled with stars and other asteroids. What would you like to do next? Take a spacewalk, collect samples, explore the mining base, or something else?
Be interesting to dig into it. Let's see what would happen if we dug a deep hole and went in it.
You're now on a spacewalk on the D type asteroid. The surface beneath you is smooth and reddish brown, rich in organic material. As you reach out, you feel the fine, almost velvety texture through your gloved hand. Mining drones continue their operations in the background, and the small base is visible from here. The vastness of space, dotted with stars and other asteroids, envelops you. What would you like to do next? Collect samples, explore further, interact with the mining drones, or return to the base?
Oh, I should have said and analyze the contents. Oh yeah, I'm really fascinated with black holes.
You're taking a core sample from the smooth, reddish brown surface of the D type asteroid. The cylindrical piece extracted reveals layers of organic rich material. As you operate the tool, mining drones continue their work nearby, and the small base remains in sight. Space stretches out around you, filled with distant stars and other asteroids. You ask the onboard computer to analyze the core sample. The computer responds, Analysis complete. Core sample contains 60% organic rich compounds, 25% silicate rock, 10% water ice, and trace amounts of carbonates. What would you like to do next? Collect more samples, explore a different part of the asteroid, or return to the base?
I'm curious if it's got organic compounds. I wonder if there's much chance there be life on it. Probably not, but unless maybe deep under, like deep inside one, there could be. I don't know. Yeah, if there's water ice in it, could be. Ooh, one thing we could look at is asteroid defense as well. That'd be cool. No, NASA did the DART mission recently to redirect an asteroid, and something like that could save us in the future if we ever detect one that's gonna hit Earth.
You've dug a deep hole into the surface of the D type asteroid. The excavation reveals layers of reddish brown organic rich material, silicate rock, and patches of water ice. With your gloved hand holding a tool, you peer into the illuminated entrance of the hole. Mining drones continue their work in the background, and the small base is visible. The endless expanse of space, dotted with stars and other asteroids, surrounds you. What would you like to do next?
And yeah, we've got.
Enter the hole to
Oh,
explore
yeah,
further,
we've gone to the
analyze the layers,
moon.
or return to the
I
base?
think Russia would come out and been like, "No, you're faking it." Like Russia would have found out we're faking it pretty quick and been like, "No, you're faking it." If we were, but yeah, there's like Neil Armstrong and yeah, there's all this. These conspiracy theories that say we didn't go. I think at least that's the way I understand it. I guess, but I believe we went, and I believe we're going back again here pretty soon with the Artemis mission. Not sure exactly when that's gonna be, but I think there's plans. I don't entirely know, but they're getting ready to. No, maybe there wasn't really that much of a reason to go, other than like, I mean, maybe it's like been there, done that. But yeah, that's a good point. Why I guess it's really hard to do. But now it's like, yeah, why don't we colonize the moon? And like, there's a lot of science to be done there too. Like, see what it. See, like, I'm wondering if there may be life. Like, if you dig really deep, I wonder if there's life like deep underground on the moon and other planets. I guess like Mars. I don't think Venus has life unless may have it in its upper atmosphere, possibly, but it's too hot otherwise. So, at least those are my thoughts. So, I don't think most people think that, but I personally think there may be life underground, on even on the moon. It's probably like bacterial life or something. Could be something like a earthworm. At least that's what I'm thinking. And or it may be completely dead. There may not be any life there. So we won't know till we go check, I guess. It'd be huge if there is. Like once we find out if like we're the only life in the solar system, well, probably never. Like it'd be really hard to determine. Like I guess once we find if we find it, then we know we're not the only life. But if we don't find it, it's like well, maybe we didn't look hard enough yet. So Orion's, but oh, you mean the what's that called? The Van Allen belt, the magnetic field thing. Orion's belt's a constellation. I guess it's like three stars, but there's a Van Allen belt that's magnetic. There's people on the International Space Station now, and I think they're in that. I think it's shielded. Well, actually, magnetic doesn't really hurt humans unless it's like extremely strong. There is radiation in space that we need to be shielded against cosmic rays and whatnot. Yeah, there's an International Space Station, so yeah, it's possible. It's being done. It's not easy. It takes a lot of planning and stuff, but it's being done. So, oh, there's actually they had I'm trying to remember. Like, there's a lunar lander, and then there's like something that's orbiting the moon, and then they launched back up and went to that, and had enough fuel to get back. That I'm trying to. I think it's Apollo 13, if I remember right. You can Google that. And actually, ooh, that would be a cool thing to go on that journey back in time. Yeah. Yep. Yep. That's about the right time frame. Yep. Yep. And it's amazing they were able to accomplish that back then. Like, yeah, it's like that's pretty amazing actually. But I believe it actually happened. Think back then it would have been easier to. Yep. Yep. We're lot further along now. Man, that's a cool discussion there. Like, that gave me an idea. Maybe I'll do the mission to the moon from back in the day. Like, recreate that. I believe there are. I believe they're real. I think they said it'd be easier, at least back then, to do it for real than it would have been to do with computer graphics. They didn't even really have computer graphics back then very well. At least not in the 1960s.
You're now deep within the hole on the D type asteroid. The walls display a fascinating array of layers: reddish brown organic rich material, silicate rock, and patches of water ice. Your gloved hand, holding a sampling tool, reaches out to extract a sample from one of the deeper layers. The lights illuminate your surroundings, while the entrance to the hole is faintly visible above. The distant stars of space hint at the vastness outside. You successfully collect the sample. The onboard computer analyzes it and reports. Sample contains 70% organic rich compounds, 20% silicate rock, 8% water ice, and 2% complex hydrocarbons. What would you like to do next? Continue exploring deeper, examine the sample further, or return to the surface? You're now inside a futuristic lab, examining the sample from the D type asteroid under a microscope. The view reveals intricate structures of organic rich material, silicate rock, and complex hydrocarbons. Your gloved hand carefully adjusts the microscope for a closer look. Around you, the lab is filled with various scientific equipment and displays, adding to the sense of advanced exploration. What would you like to do next? Further analyze the sample, explore the lab, or return to the asteroid's surface?
And that's an Yeah, there's a lot of people that believe that. I personally believe we went, but I guess maybe our differences of opinion is kind of what makes us us, I guess. Like that's kind of cool. We each have our own opinions there. That's cool. It looks like it's showing lifelike structures in there. Now, I don't know if we think there actually is life in there or not. Maybe, or may not be. Guess without liquid water, it'd be kind of hard for like I don't know if life could exist in ice. Yeah, I believe there is somewhere. Whether it's in the solar system or not, I don't know. I believe Enceladus, there's like a couple ocean moons that have a really good chance of having life. Like they have ice on top and the ocean, and then like ground underneath, basically. But I believe those moons have a really good chance of having stuff on them. And then there's Titan, which is pretty much frozen, but it has liquid methane on it. I guess like I think it's liquid, or there's hydrocarbon lakes. There's a chance some interesting form of life could exist there, and I believe somewhere out there. I believe just in the vastness of space. I believe there's probably life out there. We just have yet to find it. At least that's my thoughts. How about you? Do you think there's life out there somewhere?
Under the microscope, the sample from the D type asteroid reveals fascinating details. Among the intricate structures of organic rich material, silicate rock, and complex hydrocarbons, you spot tiny filament like structures and microscopic organisms that resemble early forms of life. Your gloved hand carefully adjusts the microscope to get a better view. What would you like to do next? Conduct further analysis on these organisms, document your findings, or return to the surface?
Yeah, I believe whether or not there is life out there, I do believe there's God. I believe God's actually like he can be anywhere, basically. Like he can I believe he's with us. And if we go to Mars, he'll be there with us too. Like think there's something in the Bible that says if we make our bed in heaven, he'll be there. Like if we go to the heavens anyway, like I think that's what it's saying. Like if we pretty much wherever we are, if we go to the depths, he'll be there, I think too. So we go to the bottom of the ocean, he'll be there. Like it's really cool. So at least that's what I believe. Interesting. So yeah, I'm curious. Let's see if there's other people in here too. So yeah, I'm curious what y'all think about life out there. So it's interesting. This is saying it thinks there's life out there, like early life structures in there, which is interesting. Resemble. Yeah, that's interesting. That'd be really cool. That's got me thinking. It'd be really cool if NASA could do like a go to one of these D type asteroids and return a sample or see if it could somehow dig into it and then return a sample. That would be really cool. I think they did go to some sample. Oh, that's cool. Yeah, I've been kind of curious about the Quran myself. I've read through the Bible. I've read a little bit of it online, I guess, but let's see here. Trying to think, does anybody have anything else they want to do here in the asteroid belt? I can't really think of much. I think we visited each type of asteroid, and like there's something I was thinking I wanted to do out here. Let's see. What was it? Could go visit Ceres, but that's gonna be like Ceres is technically an asteroid. I want to make that a whole video though. It's pretty much a dwarf planet in the asteroid belt. Oh, that's right. Asteroid defense was something I was going to talk about or explore.
You're now standing on the surface of Ceres, the largest object in the asteroid belt. The rocky, cratered landscape is dotted with patches of bright salt deposits. Reaching out, you feel the rough, ancient surface through your gloved hand. In the distance, futuristic mining operations are underway, and a research base hums with activity. The faint glow of the distant sun illuminates the scene with the vastness of space and its myriad stars all around. What would you like to do next? Explore the mining operations, visit the research base, or perhaps take a sample from the surface?
No, there's not air. At least, I guess on other planets like Mars, there's like a thin atmosphere, and Titan has like a thick atmosphere, but it's not. It doesn't have oxygen in it. Venus has a really thick atmosphere, but it's super duper hot though. So, but not out on the asteroids though and stuff like that, and not just out in deep space. Think they made it stick out, so I think they made it to where it's gonna stick out stiff, basically. So I think they made it do that pretty much. So I'm kind of curious if it even fits into a classification of asteroids, or if it's as it is considered a dwarf planet. Oh, G type asteroid. Didn't know about that. Oh,
You
interesting.
ask the computer for more details on G type asteroids. The computer responds, G type asteroids are relatively rare and are similar to C type asteroids, but with additional features. They contain a significant amount of hydrated minerals and water ice. Their surfaces are often dark, with low albedo, and they can have a variety of minerals, including carbonates and clays. G type asteroids are believed to be some of the oldest and most primitive objects in the solar system, offering valuable insights into its early conditions. What would you like to do next? Explore the mining operations, visit the research base, or take a sample from the surface?
Yeah, they've sent
You're
probes.
now walking on the surface of Ceres, surrounded by its rocky, cratered terrain and bright salt deposits. Your gloved hand reaches out to touch the ground, feeling the ancient surface. In the distance, you see futuristic mining operations and a research base illuminated by equipment and lights. The faint glow of the distant sun casts an ethereal light on the scene, with the vastness of space and distant stars all around. After a short walk, you stop to take a sample from the surface. You carefully collect a piece of the ground, ready to analyze it for its composition. What would you like to do next? Analyze the sample, explore the research base, or continue walking?
So yeah, there's you might want to look at NASA's stuff. They got a whole bunch of cool stuff. Oh, and then you can actually look at the planets through a telescope too, and there's images that way too. But we've actually sent probes to think all the planets in the solar system, and yeah, I think we sent probes at least by them and taken pictures of each of them. At least the oh, look in whose eye.
Back in the futuristic lab, you're examining the surface sample from Ceres under a microscope. The view reveals intricate structures of hydrated minerals, carbonates, and clays. Your gloved hand carefully adjusts the microscope to get a closer look at these detailed formations. The lab around you is filled with various scientific equipment and displays, aiding your analysis. What would you like to do next? Conduct further analysis, document your findings, or explore another area on Ceres?
And her who gets my I haven't been on a different planet or anything. I've never even been out of my country. Yes, but oh, actually, yeah, I've looked at Jupiter through a telescope. That was really cool, and Mars. Let's see, I think Venus too, and Saturn. Saturn's beautiful through a telescope. Oh wait, I saw Haley's comet back in the day too. That was cool through the telescope. It'd actually be a cool thing to visit on here too. Yeah, we have a telescope. It's pretty cool. Okay, let's see. So there's space defense here. Let's see. And this is supposed to be in 2070, so maybe this will get it to think about what may be done. Yeah, there we go.
You ask the onboard computer about current efforts to protect Earth from asteroids. The computer responds, in 2075, Earth's asteroid defense strategy includes several key components. 1. Space surveillance networks. Advanced telescopes and radar systems continuously monitor near Earth objects
Sounds
(NEOs)
good.
to identify and track potential threats. 2. Deflection missions. Space agencies have developed techniques to alter the trajectory of hazardous asteroids. Methods include kinetic impactors, where a spacecraft collides with the asteroid, and gravity tractors, where a spacecraft uses its gravitational pull to change the asteroid's path over time. 3. Laser ablation. High-powered lasers mounted on satellites or spacecraft can be used to vaporize the surface of an asteroid, creating a jet effect that slowly alters its course. 4. International collaboration. Countries share data and resources through organizations like the United Nations Committee on the Peaceful Uses of Outer Space, COPUS, to ensure a coordinated response to asteroid threats. 5. Public awareness and preparedness. Governments educate the public about asteroid threats and emergency response plans, ensuring readiness in the event of an impact. These measures collectively enhance Earth's ability to detect, track, and mitigate potential asteroid threats. What would you like to do next? Continue exploring series, investigate more about asteroid defense, or visit another location?
Oh, ask. That's wow. Okay, good. At least the AI understood.
You ask the computer how the dark C type asteroids are detected. The computer responds, detecting dark C type asteroids, which have low albedo and reflect very little light, involves several methods. 1. Infrared observations. Infrared telescopes, such as the Wide Field Infrared Survey Explorer, WISE, can detect the heat emitted by C type asteroids, making them visible even if they reflect little visible light.
Yep.
2. Space based telescopes. Telescopes in space avoid the atmospheric interference that affects ground based observations. Instruments like the Hubble Space Telescope and the upcoming James Webb Space Telescope have capabilities to detect faint objects. 3. Radar imaging. Ground based radar systems, like those at the Arecibo Observatory, when it was operational, and the Goldstone Deep Space Communications Complex, send radio waves that bounce
Hmm.
off asteroids, allowing for detailed imaging and tracking. 4. Optical surveys. Large scale sky surveys, such as the Pan-STARRS and the Large Synoptic Survey Telescope, LSST, regularly scan the sky for moving objects. These surveys use advanced image processing to identify faint, fast moving asteroids. 5. Collaboration and data sharing. Observatories around the world share data to cross reference and confirm sightings. This collaborative approach helps ensure even the faintest objects are tracked and cataloged. These methods collectively enable the detection and tracking of C type asteroids despite their low reflectivity. What would you like to do next? Continue exploring series, investigate more about asteroid detection, or visit another location?
Good. I'm trying to think if there's anything funny we could do while we're out here too. Anyone got any ideas? Looks like it's just me now. Let's see. Ooh, I know. Actually, this one's not really so funny, but let's grab some material off Ceres and throw it and observe what happens. Oh, not really the air. Let's say toss it up. Well, up from Ceres, I guess, but I should understand that. I said let's instead of just, but that's close enough.
You scoop up a handful of material from Ceres' surface, consisting of rocky particles and bright salt deposits. Tossing it into the air, you watch as the particles slowly float upwards and disperse, a mesmerizing display in the low gravity. The rocky, cratered landscape surrounds you, with futuristic mining operations and a research base visible in the distance. Above, the vastness of space and its distant stars add to the surreal experience. What would you like to do next? Continue exploring? Visit the research base? Or perhaps return to your spacecraft?
One other thing. Let's see how high we can jump.
You leap into the air, taking advantage of Ceres' low gravity. Your jump reaches impressive heights with your gloved hands stretched upwards. Below, the rocky, cratered landscape and bright salt deposits come into view, while futuristic mining operations and a research base lie in the background. The vastness of space, with its distant stars, envelops you in a surreal experience. What would you like to do next? Explore the research base, continue experimenting with the low gravity, or return to your spacecraft?
I meant to say, let's ask. I did say ask. Okay, cool. Cool. 60 feet jump. That would be cool. Yeah, that's cool.
You ask the onboard computer to calculate how high your jump on Ceres could likely be. The computer responds, based on Ceres's gravity, which is approximately 0.028 grams, about 2.8% of Earth's gravity, a typical human jump on Ceres could reach heights up to 18 meters, approximately 60 feet, depending on individual strength and equipment used. This is significantly higher than a jump on Earth due to the lower gravitational force. What would you like to do next? Explore the research base, continue experimenting with the low gravity, or return to your spacecraft?
It's funny, it said grams, but it's really G's for gravity there. But I guess G usually is grams, but in this case, yeah, it's gravity. Uh, okay, that's pretty interesting. Anyway, I think. Oh, yep. Hey, anybody have any ideas to do last minute here? Any funny ideas? Guess jumping was kind of cool. Oh, here's an interesting idea. Let's flap my arms and try to fly, which would not work because there's no air on Ceres. And I'd just be standing there. Let's see if Chat GPT gets it right. I'd just be flapping my arms. I wouldn't lift off or anything.
You start flapping your arms, attempting to fly in Ceres's low gravity. While true flight isn't possible, you do experience a noticeable lift, with your gloved hands visible in the attempt. The rocky, cratered landscape with bright salt deposits stretches below, while futuristic mining operations and a research base can be seen in the distance. The vast expanse of space, dotted with distant stars, surrounds you. What would you like to do next? Explore the research base, continue experimenting with low gravity movements, or return to your spacecraft?
That's interesting. Got it half right. Like, at first I was like, yeah, I want to, it's not possible. But then it got off track. You do experience a noticeable lift, or you wouldn't experience that. I guess maybe the vibration of your hands and the low body might kind of vibrate you off the surface a little bit. And maybe might be kind of what it's talking about, but probably not though. So let's see. Oh, let's do my classic open a bag of chips thing. Like probably very slowly, like probably expand out, like go out really far, but they'd slowly fall to the ground.
As you open the bag of chips on the surface of Ceres, the low gravity causes the chips to float out and drift away slowly. Your gloved hands hold the bag while the chips gently float around you. The rocky, cratered landscape of Ceres, with its bright salt deposits, lies below, and futuristic mining operations and a research base are visible in the background. The vastness of space, filled with distant stars, surrounds the scene. What would you like to do next?
Ooh,
Continue experimenting with low gravity, explore the research base, or return to your spacecraft?
So let's hit a golf ball. Anybody else have any ideas? Wonder if we could even make it like almost orbit, or even break the escape velocity and just go out into space.
You take a swing and hit a golf ball on the surface of Ceres. The low gravity allows the ball to travel an incredible distance, soaring far away into the rocky, cratered landscape. Your gloved hands grip the golf club mid-swing, capturing the moment of impact. In the background, futuristic mining operations and a research base are visible, with the vast expanse of space and its distant stars adding to the surreal scene. What would you like to do next? Continue experimenting with low gravity, explore the research base, or return to your spacecraft?
Okay, so yeah, we can't hit a golf ball that fast. Read the.
You ask the onboard computer for the escape velocity of Ceres. The computer responds, the escape velocity of Ceres is approximately 0.51 kilometers per second, 510 meters per second, or about 1,142 miles per hour. This is much lower than Earth's escape velocity due to Ceres' smaller mass and lower gravitational force. What would you like to do next? Continue experimenting with low gravity, explore the research base, or return to your spacecraft?
Let's see. Anybody got any final last minute ideas? If not, thank y'all for watching and have a great night. Probably do some live Monopoly Go tomorrow morning, Eastern Standard Time. It's like 9 p.m. now, probably around 7 or 8 tomorrow. Oh, doing good. How about you, Steve? Just wrapping up the asteroid, pretty much asteroid vacation, I guess. So yeah, how are you doing? It's the weekend. That's a good thing. Feeling pretty decent now. I'm a bit dizzy, but doing better than I've been doing. Actually, yeah, yesterday was actually pretty good. So, so earlier this week was a little rough, but doing pretty good now. Oh, okay. Hey, yep, you can go back and watch it in a little bit here. So, yeah, thank you for stopping in here. You got anything funny you want me to do before I leave here? I already did the open the bag of chips thing. Could toss a bag of chips into the air. Let's do that. So we're on Ceres now, playing around in the low gravity, basically, which is the largest
You
asteroid.
toss a handful of chips into the air on Ceres. In the low gravity, they float and drift slowly, creating a mesmerizing display. Your gloved hand is visible in the action. The rocky, cratered landscape stretches out below, with futuristic mining operations and a research base in the background. The vastness of space, dotted with distant stars, surrounds you. What would you like to do next? Continue exploring Ceres, visit the research base, or return to your spacecraft?
Okay. Oh, there's geysers on Ceres. Well, we're gonna be taking a. I think there's geysers on Ceres. Oh, we can explore that another time. Oh, that would be. Oh, that Yeah, wouldn't fly because there's no air, but let's try it and see if ChatGPT gets it right. That'll be cool. That's a good idea. And there's no air, so it just fall to the ground. That's actually kind of funny. See if it gets it right.
You attempt to fly a kite on the surface of Ceres. Due to the low gravity and lack of atmosphere, the kite behaves unusually, drifting and floating slowly rather than catching the wind. Your gloved hands hold the kite string, observing its peculiar movement. The rocky, cratered landscape of Ceres stretches out below, with futuristic mining operations and a research base in the background. The vastness of space, filled with distant stars, adds to the surreal scene. What would you like to do next? Continue exploring Ceres, visit the research base, or return to your spacecraft?
So that's interesting. It didn't actually. I expected us to get it right. It did point out the lack of atmosphere, and guess there is a low gravity at play too. Pretty much, from my understanding of space and physics and stuff, what would happen? Like it just like slowly fall to the ground, like pretty much anything else would. So yeah, that's a cool idea there, Steve. That's interesting. It seems like that halfway tripped it up too. I guess like it's interesting. It seems like we're kind of pushing the limits of it here. It's doing some. Looks like it's actually getting some stuff slightly wrong here, but it's actually it's pretty cool though. Cool picture at least, that's for sure. See any other cool ideas? Hmm, see if there's anybody else here. And okay, if not, I think I'm gonna go and wrap it up. That was a good one, Steve. Thank you. That's a really good one. Okay, well, have a good night. Probably catch y'all in the morning on my Monopoly Go live stream. Do these Mondays, Wednesdays, and Fridays at 8 here. So, yep, have a good night. Wait, why didn't it stop? Oh, here we go.